Okay, so we were discussing, actually we have started the numerical related to connections, and we saw this numerical. In this there are three cases, and we are supposed to identify the strength of the bolted connection for three different conditions. First is the lap joint, second is single cover butt joint, and the dimensions are given, and the double cover butt joint connection. So in the previous lecture we have seen calculation of the design strength of the bolt in single shear, and we were about to discuss about the strength of the bolt in bearing. I hope you people have understood the various terms for calculating the strength of the bolt in shear. So these are the different terms, and you are supposed to write down the clause number in this manner, page number as well. So you should make a practice that whenever you are referring any formulation, you are supposed to mention the clause number and the page number. Now as far as your exam is concerned, uh, there may be a chance that you will get such numerical wherein three different or number of cases may be there, and you will see that every time the formula is getting repeated. Okay, so for example in this case itself we will see the formula for calculation of strength of the bolt in shear and bearing, that is going to get repeated. In such cases what you are supposed to do is you are supposed to mention the clause number and page number and the formula only once. Okay, and it is not necessary that you should repeat it for the next time, but for at least once you are supposed to mention the complete details. Okay, so in examination make sure that you should mention the clause number, page number, table number, whatever the reference, whatever may be the reference, at least once. Is this okay? Okay, and but this is only meant for your exam purpose. Remember, whenever you prepare some report, while report formation, make sure that everything should be mentioned everywhere, every time. There should not be any kind of uh, lacuna. Okay? Everything should be mentioned. So anyway, I hope you have understood this explanation till the calculation of strength of the bolt in single shear. Now let us see how to evaluate the strength of the bolt in bearing. So this is the formulation. V and B is equal to 2.5 times KB D into T into FU. Actually, this you will get in your IS 800 2007. I again request all of you to please open the IS code. If you have not, please open it right now. I will also show you the exact page number and what is the exact formulation. So this is on page number 75. The formulation to calculate the strength of the bolt in bearing condition. Okay, so let us see that. This is the formula as you can see over here. Okay, VDPB is equal to VNPB divided by gamma MB. And what is VNPB? This is nominal bearing strength of the bolt, which is expressed as 2.5 times K suffix B into D into small d into F suffix U. What are the meanings of all these terminologies or terms? देखो, KB is smaller of these four parameters. What are these? Small e divided by 3 times d naught, comma, p divided by 3 times d naught minus 0.25, then FUB divided by FU, and 1, whichever is less. That value shall form KB. What is small e? Small e is the end distance and small p is the pitch distance of the fastener along bearing direction. Okay, so actually pitch is nothing but the center to center distance between the bolt. Okay, in your IS code it is specially mentioned that if this direction center to center distance is parallel to the direction of the stresses, then it is known as pitch. But you can consider the center to center distance between the bolt to be pitch distance, right? Or it is known as pitch. Small e, especially over here, it is mentioned as end distance. So if you remember, we had discussed about the end and the edge distance. There is a difference. So we will come across this end and edge distance very particularly while finding out the strength of the bolt in bearing. So we will do that. D naught is the diameter of the hole. FUB and FU are the ultimate tensile stress of the bolt and ultimate tensile stress of the plate respectively. ठीक है, यहाँ पे जो है ये FU ultimate tensile strength of the bolt, you can even modify this and you can write it over here as FU suffix UB, I mean F suffix UB, okay, as mentioned over here. Then D is the nominal diameter of the bolt, and this is very tricky. This is what it says: summation of the thickness of the connected plates experiencing bearing stresses in the same direction, or if the bolts are countersunk, the thickness of the plate minus one half of the depth of the countersinking. ये countersunk जो है, I will be explaining you later on. Our area of interest is this: summation of the thickness of the connected plates experiencing bearing stress in the same direction. ये मैं explain करूँगा आपको, ठीक है? So these are the terms which are included in order to calculate this B and PB value. Okay, so let us try to evaluate. This is the reference which I have shown. Now, KB is minimum of this, but the small p, P is what? Pitch of the connection, pitch of the bolt. Now see, initially how to calculate the P value, how to evaluate this E value, because we don't have any information related to small e or P anywhere in this numerical. Okay? So we have to consider some initial values which are definitely based on the IS 800-2007 clauses. We will be referring those. We will be giving the references of these things, and then we will be evaluating some initial value. Because as you can see in this formula, in order to calculate KB, we don't know what is E value. We know what is D naught. That has to be evaluated again from the IS code. We don't know P value. We have only the values for FUB and FU. That's it, isn't it? So let us see how to initially evaluate the P and E values. Small p, as per your IS code, which is given on page number 73 in this clause, P is equal to 2.5 times the nominal diameter of the bolt. And D naught is given as diameter of the hole. This diameter we will be calculating from the table 19, which is given on page number 73. So let me refer page number 73. ठीक है, तो देखो यहाँ पे ये मिनिमम स्पेसिंग का एक क्राइटेरिया दिया हुआ है. What it says, distance between center of fasteners shall not be less than 2.5 times the nominal diameter of the fastener. Okay, ये क्राइटेरिया दिया हुआ है. Based on this, we can identify the value of pitch, that is small p. Are you getting me? Yes or no?
Yes, sir.
So fine. So this small p value is opted from this clause, 2.5 times the nominal diameter of the bolt. Then D naught is, what does D naught stand for? Diameter of the hole. Okay. So if you remember, I had told you this diameter of the hole should be more than the diameter of the bolt, nominal diameter of the bolt. The reason is very clear. In order to have easy uh, insertion of the bolt into the hole, and then you are in a position to tighten it later on. So that clearance should be there. There should not be any kind of uh, contact between the bolt and the plate surface. There should be some clearance. That clearance is given in this table, as you can see, and be careful. The column number 2, which speaks about the nominal size or nominal diameter of the fastener. So there are different ranges which are given. For different ranges, you will see that there are different sizes of the holes which are mentioned. And what it says, size of the hole is nothing but nominal diameter of the fastener plus clearances. So ये जो है ना ये value, these are nothing but clearance values. First, rather the third column, it says standard clearance in diameter and width of slot, oversized clearance in diameter, clearance in length of the slot, short slot and long slot. Uh, as far as our study is concerned, we do not have to look into the oversized clearances and short slot and long slot right now. We will be only studying about the standard clearances. First of all, let us try to understand how these standard clearances are maintained based on the different sizes of the bolts or diameter of the bolts. And then later on, for very typical cases, which you may study in your further semester in elective or so, in that case, you will be learning about the oversized clearance and all. So our interest is this column number 3. So these are the clearances which are mentioned in your IS code for different diameter. So let me know what is the nominal diameter of the bolt given in our numerical. How much it is? It is 20 mm. Okay. So for 20 mm diameter bolt, what clearance value is mentioned? It is 2 mm. Got it? So the size of the hole, which is represented by D naught, size of the hole or diameter of the hole, one and the same thing, it is represented by D naught. So as per the clause, what should be the D naught value? It should be 20 plus 2, that is 22 mm. Got it? Then slowly you substitute the values, but before that you should know what is small e value, isn't it? Small e value, as we have discussed earlier, as per end and age distance clause. So this is again mentioned on the page number 73. No, not on 73. 1 minute. This clause for end distance. So where did we see the end distance clause? Over here, that is your 10.2.3.3. That is page number 74. So I will read it one more time. The minimum edge and end distances from the center of any hole to the nearest edge of the plate shall not be less than 1.7 times the hole diameter in case of sheared or hand flame cut edges, and 1.5 times hole diameter in case of rolled machine flame cut, sawn and planed edges. So unless and until the edge formation condition is given, you can consider any of these values in order to find out small e, that is the end distance. Okay, so we will assume initially 1.5 times the diameter of the hole, unless it is mentioned. Okay. Well, with that, what we did, uh, E is equal to 1.5 times the diameter of the hole as mentioned in this clause. It is the hole diameter. Okay. So 1.5 times into D naught. D naught you have already evaluated it. It came out to be 22. So from this E comes out to be 33 mm. Right? Small p 2.5 times D. D is the nominal diameter of the bolt. So this is given as 20 mm, so it comes out to be 50 mm. Now after finding out the E and P values, then now you are supposed to uh, mention or identify these parameters: E divided by 3D naught, P divided by 3D naught minus 0.25, and you know what is FUB and FU, that already you have mentioned in this first given condition, right? And then 1. So whatever may be the least value out of all these things, that will form my KB value. So I have left out these spaces, so you can calculate. And as per our calculation, I think minimum of all these four, it will come out to be 0.5. Please check. How much does this second point come out to be? 50 divided by 3 into 22 minus 0.25. How much? 0.5. Okay, it also comes out to be 0.5. ठीक है. And this is more than 0.5. This is zero point 0.9 something, isn't it? And this is 1. So minimum is 0.5. So we have evaluated the value of KB to be 0.5. Okay. Now the next part is to calculate VDPB. VDPB in the sense, पहले तो VNPB calculate करते हैं. VDPB is nothing but VNPB divided by gamma MD. If you remember this formulation, VDPB is nothing but VNPB divided by gamma MB, and VNPB is this value. So we have calculated KB. We know what is D. Okay, this D is the diameter, nominal diameter of the bolt. FU, you know what is FU value. Okay, FU, as per this statement, it is written as ultimate tensile stress of the plate. कितना दिया है वो? 410. ठीक है. Now the major part is of calculation of T. देखो यहाँ पे T लिखा है ना, small t, and as per the definition of small t, it is summation of the thickness of the connected plates experiencing bearing stress in the same direction. ठीक है. Or if the bolts are countersunk, the thickness of the plate minus 1/2 of the depth of countersunking. Countersunk का मतलब होता है the bolts which we have seen earlier, the shape and all. So generally the shape of the bolt is hexagonal. I mean the head is hexagonal in shape, and there is no such slanting formation of the head. If such kind of slanting formations are there, just like your screw, this is known as countersunk bolt. Okay, so if we are making use of such kind of countersunk bolt, then you are supposed to consider this value, whatever is mentioned over here, for small t. But our bolt is not countersunk bolt. It is a plain, I mean the usual bolt, black bolt, or the uh, what you can say, the bolt which we consider for steel construction purpose, right? So what is the summation of the thickness of the connected plate experiencing bearing stresses? Now just Try to understand. Summation of thickness of the connected plates experiencing bearing stress in same direction. देखो, in our case, in the first case actually, in this case, we have a bolt like this and the plates are connected like this. Here actually what is happening? There are only two plates. ठीक है? And because of these two plates, the bearing stresses, if let's say force on this plate and on this plate, they are acting in this manner. So the bearing stresses uh, on this face, because this face will come in contact with the bolt. So the direction of the stresses shall be opposite, like this, something like this. Okay? Whereas for this, the direction of the stresses on the bolt surface will be like this. These are the bearing stresses which I have drawn. Okay? Now, यहाँ पे वो क्या कहता है कि summation of the thickness of the connected plates experiencing bearing stress in same direction. So, do you find that these bearing stresses are acting in the same direction for this particular case? Do you see what is the direction of these bearing stresses on the left side, whereas the direction of these bearing stresses are on the right hand side? Do you agree?
Yes.
Now, uh, since this condition is not getting satisfied for a single shear, because the both the bearing stresses are facing opposite to each other, in such case, you are supposed to identify or mention the thickness of the plate in such a way that out of the connected plates, whatever will be the least value of the thickness, that needs to be considered, right? Now, fortunately, in our case, the thickness of both the plates, whatever is given, is 12 mm. Okay? So, you are supposed to consider T to be, T will be equal to 12 mm. That means you are supposed to consider only one plate dimension. Although it is written summation over here, but the condition is that summation of the thickness of those plates which are experiencing the bearing stresses in the same direction. यहाँ पे तो वो नहीं है. That possibility can be there when we will be experiencing double shear effect. Okay? तो ये देखो, ये जो figure है. Can you see this figure? In this figure, as you can see, the bolt is experiencing double shear. In this case, we will have to then check the thickness, which will be minimum, T minimum, out of the two cases, that is whatever value of summation. Okay, in this case you can see the bearing stresses over here and over here, they are acting in the same direction. So what I will be doing, I will add both the thickness of the plates and then compare with the other plate whose bearing is in the other direction, whose bearing stresses is in the other direction. So least of minimum of these two will govern my small t value. Okay, so I will be coming over here in the next part of the discussion. But in our case, since this bolt is experiencing the bearing stress only in one direction, in that case we are supposed to check what will be the minimum thickness which is given in the problem, that has to be considered. Okay, so therefore T will be equal to 12 mm, since both the plates given in this numerical are of 12 mm thickness. If this thickness was 10 mm and if this thickness of the plate was 12 mm, in that case you would have considered the 10 mm thickness in your formula, in this formula. Okay, so whatever is the minimum value of the thickness, that is to be considered. The reason is very simple, because thinner the plate, it will experience more force, or more forces will be attracted towards it, because it won't be in a position to carry the load, expected load, isn't it? Because you know, stress is nothing but load by area, isn't it? So it is, everything is proportional. Therefore, it becomes very critical, and hence we need to consider t value to be least value. I hope this is understood. Okay, so we have considered 12 mm over here. So you substitute all the values and you will get the value of VDPB to be 98.4. So see, VDPB I have directly calculated. So while calculating VDPB, I have also considered the gamma MB value. Gamma MB. Gamma MB we have already jotted down from the IS code. It comes out to be 1.25. Okay? So these are the values. This is the strength. This is the strength of the bolt in bearing and shearing. Okay? But we are supposed to identify the strength, final strength of the bolt, and the final strength of the bolt will be nothing but the minimum of shearing and bearing. That is the critical value. This becomes the critical value. Okay, minimum, least value. Fine. So this came out to be 45.26, and this is 98.4. Minimum of this will be governing the design. For this, we have to take care. This is the actual capacity, and beyond this capacity, it will not be able to sustain the load. This is the ultimate capacity of that bolt. Okay? Right. The next, second case, here butt joint connection is given, and in case of butt joint, two plates of 12 mm. This is the thickness of the two plates. This is one plate, first plate and second plate. This is getting connected in the form of butt joint connection with the help of third plate, which is of the dimension 10 mm. Okay, this is the typical arrangement. Fine. So as I have mentioned over here that the number of shear planes is 1, Nn will be equal to 1, and Ns will be equal to 0. So do I need to explain this one more time, or you have understood this? Why I have written Nn equal to 1 and why Ns is equal to 0? Is this understood? I will ask one more time, because this is essential for you people to understand at this stage itself. Have you understood this? Why Nn is equal to 1, why Ns equal to 0? So what is the definition of Nn? What Nn stands for? Yes.
Number of shear planes with thread interacting with shear plane.
Correct. So that plane should cut the threaded portion, or that plane should consist of threads. Then the value will be some value. Okay, and Ns is nothing but reverse of that. So there are no threads. So such situation is not there in our case, because we are considering that the threaded portion is quite long and it is sufficient enough so that the plane, whatever plane, cutting plane or shear plane is there, that will consist of the threaded portion, and hence the NN value is 1, NS will be 0. So we know that the shear planes are 1, rather it is 1. So this value is 1, NN is 1. A and B you have already calculated. What is the basis of calculation of A and B? We have assumed 0.78 times uh, the area of the bolt. 0.78 into pi d square by 4, small d square by 4. Okay? So with that, you have evaluated the A and B. Gamma and B, you have found from the IS code. Then it is easy to calculate VDSB, okay, with the formula. So see, I have not repeated the IS code clauses over here. Since I have written it, mentioned it in the case number 1 itself, over here it is not required from your exam point of view. I am telling you, okay. This will uh, this will save your time certainly. Okay. Then strength of the bolt in bearing, same formulation, same assumption. So need not to recalculate the KB value. You have this KB value, T you know, and now what should be the value of T? Although I have written this 10 mm, although I have written this 10 mm, but have you understood why this is 10 mm? Because you see, these are the plates and this is the bolt. Okay, if this is the force, then this portion it is experiencing bearing stress in this direction, whereas this portion of the bolt is experiencing bearing stress in this direction. Both are actually facing opposite to each other, so there is no question of finding out summation value, but you are supposed to calculate the minimum thickness out of these two. So minimum thickness out of these two is 10 mm. Therefore, this T value is 10 mm. 410 is the FU value. Gamma MP is 1.25. From here you get VDPB value. Again, the strength of the bolt will be minimum of bearing and shear, which comes out to be this value. Got it? Isn't this simple? Right?
Yes, sir.
Fine. Now the next part, that is the butt connection is there, and there are two plates actually on the top as well as the bottom of the plate of these two plates, and you are now supposed to calculate the strength of the bolt with respect to this figure. It is very much clear that there are three plates. No, see, one thing you should remember in butt connections, you are supposed to consider one section, okay, and either you solve for this left hand side or right hand side, okay, that is up to you. That means this left hand side will form half connection and this half connection. So even if you solve for any of the directions or sides, that will be true for the complete connection. For example, if you consider this left hand side, and if you design in the sense, so what did I tell you for design? Design is nothing but deciding dimensions. In steel structure, it will be in addition to decision making of dimension, you are supposed to identify the number of bolts. Okay, so if even if you design or find out, calculate the number of bolts on this side, that will be true for this side also. Okay, because the forces which are expected, they are same, equal and opposite. Okay, so like that. Anyway, so I will consider, let's say, this part left hand side, and how many plates do you find to be connecting? One, two, and three. There are three plates, isn't it? So for 3 plates, what should be the NN value?
2.
2. And remember, again I will be repeating, we will consider all the shear planes to be having the threaded portion. So NS will be automatically 0. Okay, NS will be 0. So unless it is mentioned, you are supposed to assume this thing. This will reduce your calculation effort. Unless and until it is very much essential. Okay. Then, with this understanding, you calculate the strength of the bolt. But over here, it will be in double shear. Okay. So VDSB will be equal to this value. I need not to repeat. I have further reduced the formulation based on your based on the explanation which I have given and based on your understanding. I hope that you have understood why this formula has reduced to this value, because NS is 0. This is A and B. This is A and B value. Okay? And then you have calculated the VDSB. I have not written the value. You can find out. Now here NN जो है, this instead of 1 it is now 2. So whatever value you have calculated earlier, it is just twice of that. Then strength of the bolt in double bearing. Okay, over here now we need to understand this figure. ये देखो, यहाँ पे अभी आपका summation value आएगा. Summation of the thickness of the connected plates experiencing bearing in same direction. So can you see in this figure, this bearing stress and this bearing stress, they are acting in same direction. So associated plate thicknesses are 8 mm and 8 mm. Do you agree? Yes. This is 8 mm thickness plate. This is 8 mm thickness plate. Right. So you add them. This will form the summation. Whereas if you see over here, which is associated to the 12 mm thick plate, the bearing stresses are acting in the opposite direction to this. And there is no other bearing stress which is in the same direction or parallel to this. So it will be only 12 mm. But while identifying this small t value, you should make sure that the value, whatever you will be substituting, it should be least amongst whatever you have identified. So therefore, out of this 16 mm and 12 mm, least value is provided over here. Have you understood this thing? So I have written separately over here. Minimum of 8 plus 8 and 12 mm. Have you understood this thing? Please let me know. Yes, in case of any difficulty, you can ask. Is this okay?
Yes, sir.
ठीक है. So therefore, this 12 value is introduced over here. And you can then calculate the VDPB. Whatever will be the least value amongst these two, that has to be considered as your this thing, design value or strength of the bolt. Then कितना आता है? Just let me know. Can you please let me know? VDSB कितना आता है?
But this we need to divide the data from the supply design.
Yes, that should be there. Correct. Because this is design. This has to be divided by 1.25. That is good.
Maybe 98.5.
Okay, 98. ठीक, whatever. And what?
92.52.
अच्छा 90, okay, 90.52 kilonewton, huh? Unit should be kilonewton. And what about this VDPB? 98.4 kilonewton. ठीक है. So in any case, just remember whenever you design, whenever it comes up to the design of any connection, make sure that the strength of the bolt in bearing should be always more than the shearing strength, because we don't want the connection to be failing in the bearing stage itself. We should allow it to allow the capacity of the bolt to be good in bearing. शेयरिंग में तो ठीक है, फेल हुआ तो भी कोई प्रॉब्लम नहीं, राइट. वहां तक पहुंचना चाहिए, शेयरिंग तक पहुंचना चाहिए, दैट ओके. सो ठीक है, नेक्स्ट. नाउ just the beginning of this I will be explaining you this numerical. It deals with packing plate, the thing that beta pkg, that value will now come into picture, and there will be a change as far as the design strength value is considered. For bearing and shearing, that value has to be multiplied, not for bearing but for shearing. You will see that beta pk value will have to be incorporated. So what this problem states, there are two plates 10 and 18 thick, jointed by double cover butt joint for the following data. Factored design load 750 kilonewton. Bolt diameter is given as 20. Steel grade is Fe410. यहाँ पे mention किया है. Bolt grade is 4.6. Cover plates are 2 on each side of 8 thickness. So just try to understand what is given. Okay, एक है 18 thick plate, and this 18 thick plate is to be connected with another plate which is of 10 thickness. So you can see there is a gap. Can you see this shaded portion? This is a gap. Initially you can consider this to be a gap, and you are supposed to connect this complete thing with the help of two plates which are of dimension rather thickness 8 which will be lying on the top and the bottom of these two plates. So such kind of connection is to be conducted. Since there is a gap, this gap is now to be filled, because we cannot leave this gap as it is. We need to consider some filling material. That filling material is nothing but plate. We call it as a packing plate. So यहाँ से लेके यहाँ तक, and this space, in these two spaces we will have to provide some packing plate arrangement, right? So what will be the effect, right? How the values will change, that thing we are supposed to assess. Before assessing, you write down all the given values. Okay, I have mentioned all these values. We have already discussed all these terms. Nothing is new. So ये जो DH है, DH is nothing but diameter of hole. Instead of D naught, this I have considered as DH. Terminology is bit different, but the meaning is same. Diameter of the hole. Gamma MB, gamma M1 will be now required in our case. And what is gamma M1? What is gamma M1? Which table provides you this information of gamma, a partial safety factor? Yes. What is the table number? Can you please help me? What is the page number? 30. Okay. So over here as you can see, resistance governed by ultimate stress. This factor now will be required in our this numerical. So therefore, gamma m1 value has been introduced here. Okay. So now see this packing plate. I could have placed it here also. And it is not mandatory that this plate of 10 should lie uh, above the bottom cover plate, or it is not necessary. ये यहाँ पे भी रह सकती थी 10 plate like this. It is not hard and fast. So this is the 18 thick plate, you can say, and the 10 plate could have been over here also. There is no such hard and fast thing. Okay, like this, and this is the top cover. This would have formed the bottom cover, something like this. And then this, whatever is the blank space, that is this portion, this shaded portion you can consider, and this shaded portion, that can be filled with the packing plate like this. Okay, so we will see uh, what are the changes and what should be done in order to calculate the strength. Uh, Bolt will experience double shear and bearing because there are three plates, as you can see. Since two plates to be joined are 10 and 18 thick, packing plate arrangement is required. And since this is completely 18 this remaining space will be, obviously it will be 18 minus 10, which is 8 So that shall be required. Also, the packing plate is thickness is 6 Hence, this beta pk value needs to be considered. Now, there is one more clause. Actually, it is written. Page number again 75. ठीक है? कहाँ गया 75? Yes. The see the design shear capacity of bolts carrying shear through a packing plate in excess of 6 shall be decreased by this amount. तो 6 अगर रहता तो we would not have considered this formula. If it is in excess, then we need to consider this. So you can calculate this beta pk value 1 minus 0.0125 into tpk, thickness of the plate, packing plate. Simply you find out this value and calculate beta pk. Next for portion of calculation we will be discussing in the next class, tomorrow's class. So I will stop over here. Okay, you people can leave.